slope of a straight line. The slope is a measure of the steepness of a line as we go from left to right in a coordinate plane. If you go from left to right and we find the line is increasing, the linear equation is increasing in value, we say that it has a positive slope. If you go from left to right and we see that the line is decreasing, we say that it has a negative slope. If you go from left to right and there's no change, it doesn't increase or slope upward or downward, it stays level, it has zero slope. If if a left or right does not exist, then the slope is undefined and it is a vertical line in that case. The slope of the line between 2 points is the ratio in the change in coordinates, in ratio of the change in y coordinates to the change in x coordinates. So you can see that here. The slope is simply a ratio of the change in y coordinates divided by the change in x coordinates. And algebraically, there could be y2 minus y1 divided by x2 minus x sub 1. The numbers that are here are called subscripts, the 2 and the 1. They simply mean a different instance of the same thing. A different instance in y coordinates, a different instance in x coordinates. That's all subscripts mean. So our formula for the slope is right here. M is equal to y2 minus y1 divided by x2 minus x1. Now, here we have find the slope containing the 2 points. So we plug in our x and y coordinates. We subtract here. So we have 5 minus 0 and 4 minus negative 2. And we have 5 over 6. So a positive slope is increasing from left to right. So what this slope means is that the rate of increase, the ratio of the increase is going to be the same from one point to the next. This ratio of the change in y divided by change in x will be the same from one point to the next. So up 5 points, up 5 units, and change over 6 units, and then up 5 units and change over 6 units. The ratio is going to remain the same from one point to the next. You see that here, if I start a point on the line at negative 2, 0, then I apply that ratio here. The change in the y coordinates is at a plus 5, and the change in the x coordinates is a plus 6. So the next unit is going to be at a 4, 5. We can repeat this overall because the ratio of the change will be the same from one point to the next. The next one will be at 10, 10, and we can repeat this on and on. Now, in this particular technique here, since we have 3 points, we could graph 3 points on the line, all because we know the slope and a point on the line. So given a slope and a point on the line, we can graph the line just from knowing that. Because that ratio is the same from one point to the next. The change in y, the change in x. Now they have another case to find the slope containing different points. So you plug in here, we have x2, y2, and x1, y1. So we plug in. So you're going to have 2 minus 4, and then 4 minus a negative 3. Take your time and set up the problem first completely. Then do your computation. Then we simplify it. In this case, it's negative, so the line is going to be decreasing from left to right. In this next one here, notice we have 2, negative 2, and 4, 2. Notice that the y coordinates are the same. So when we plug in, we have 2 minus 2 is 0. We have 0 slope. In this case, we have a horizontal line. Sometimes you can notice little things like that. Notice the y coordinates are the same. In the next case, it's another special case here. Notice that the x coordinates are the same. So when the x coordinates are the same, that means they're going to be right on top of each other. So I have 3 minus a negative 2. And I have 1 minus 1, which just gives me division by 0, which is undefined. And in this case here, we have a vertical line and the slope is undefined. And this leads us to something called the slope-intercept form of the line. What makes this particular form of a linear equation unique is that just from glancing at it, we can see a point, and we can also see the slope just from looking at it. So given the slope and y-intercept, we can find a point, we can graph the line just from looking at it. Y is equal to mx plus b. We can identify the slope as being 5/3, and where it crosses the y-axis, when x is 0, y is negative 4. So I have a point here. There's my y-intercept, and I have a slope. So I know the change in the y-coordinates to one point, the ratio is going to be the same from one point to point. And the change in the y-coordinates is going to be increasing by 5. And the change in the y-coordinates is going to be increasing by 3 from one point to the next. So my next point is going to come from 0 and 3 is 3, negative 4 and 5 is 1. I got my second point, but then I can repeat that ratio and I get 6, 6. I have 3 points. I can graph the line. In this case here, we can graph the line by using a slope and y-intercept. So the first thing we do is solve it for y so we can identify the slope and y-intercept. So take x squared, and I take x plus 2y equal to 4, and I subtract x on both sides. Then I divide everything through by 2, and that gives you my equation in slope-intercept form. I can identify my slope as being a negative 1/2. My y-intercept is going to be at the point 0, 2. So I know what my slope is, and I know what point on the line is. My change in y is going to be at a negative 1 from one point to the next, and my change in x is going to be increasing by 2. So 0 and 2 is 2, and 2 and minus 1 is 1. Then I can repeat this, and I got 3 points now. I can graph the line. So in this particular case here, they say graph the line that goes through a point negative 4, and has a slope of 2. So we know what the slope is, and we know a point on the line. And we know that the slope is 2, so my change in y in this case is going to be increasing by 2, and my change in x is going to be increasing by 1. So I can repeat this. Negative 4 and 1 is 3, and negative 4 and 2 is 2. I have my second point. I can repeat it and get my third point. Now I have 3 points. I can graph the line. Now, had I made a mistake in my algebra, I'd have a triangle here.